All right, so welcome back to our TensorFlow series. This is lesson 2. I am Ibrahim Malik, and today we are taking your AI skills to the next level. Remember, in our last lesson, we taught AI to recognize number patterns. Uh, well, today we are going to do something even more exciting. We are going to teach a computer to read handwritten numbers. Okay. So imagine having an AI that can look at a number you have written and instantly recognize it. Okay. That's exactly what we are building today. And the best part is not as complicated as you might think. Okay. So before we dive into the code, let me show you something fascinating about how computers see images. Okay. So the screen that you see, look at this grid, right, on your screen. While we see a handwritten number, right, what we see is the handwritten number. The computer sees a grid of numbers, specifically a 28 by 28 grid, where each number represents how dark or light that a spot is, right? 0 means completely white, and 255 means completely black. So this is crucial to understand. Computers don't see like we do. They process these numbers to find patterns. Think about how you recognize number 8, right? It has two loops, one on top of the other. The computer finds similar patterns, but in numbers, okay? So to process these patterns, we use something called a neural network. Now, don't let that term intimidate you. As I said in previous lecture as well, a neural network is inspired by how our own brains works. Just like we learn to recognize numbers by seeing many examples, our AI will learn by looking at thousands of handwritten numbers. Okay. All right. So while you are, you see how I want to show you how I generated this as well, right? So basically, just like other exercise, we imported TensorFlow, STF, and matplot library, and NumPy, right, as NP. Then we're loading MNIST dataset. So MNIST, this keras datasets MNIST, and then we're gonna training at X and Y, X train, Y train, and X test, Y test, right? Uh, then we're telling it to select first image and then create figure with two subplots side by side. All right. Uh, Plot one, original image, right, is to what we see, and this is the plot that you saw before, where we had what we see, right? And in the plot two, which is the second grid, right, it's what computer sees. Okay. All right. So when you run this, okay, let's run this again, just for the giggles. Okay, it ran and it generated the same fives. All right, so that's the first part. All right, before we dive into the code, let's quickly understand how AI recognizes images. Uh, Computers, as we've said, right, don't see images like we do. They see numbers. Uh, so each pixel in an image has a brightness value between 0, which is black, and 255, which is white. When we give an image to an AI, it analyzes these numbers and tries to find patterns. Okay. And to recognize patterns, we use something called a neural network. I mean, think of it like a human brain. It learns by looking at thousands of examples. Okay. So let's start coding. All right, we're going to train an AI to recognize hand written numbers using the MNIST dataset. All right. So again, we are already at collapse. So let's go and open a new notebook. All right, now that we have a new notebook, let's give it a title already, and we're calling it TensorFlow Lab 2. Okay, so that's that. Now we're going to be doing is we're going to import uh, import data set from MNIST, which contains, I believe, up to 70,000 images of handwritten digits. Okay, so it comes, TensorFlow comes with a built-in data set called MNIST, and that's what we're going to use. All right, so let's start by importing. I'm gonna first title it import TensorFlow. Okay, we'll import TensorFlow STF. From TensorFlow, we'll import Keras, and we'll import the matplot library. Okay, I will also import NumPy as NP. Okay, now let me run this. Give it a minute. All right, so it looks like it ran, right? And it was successful, okay, which is good. All right, so now what we're going to do next is that we will load the MNIST dataset, okay? So we'll pretty much just, we'll load MNIST dataset, then, all right. And to load the MNIST dataset, we're going to run this command. You'll have all the code. So if you're following along, or if you want to do it again later on. All right, so I've done that. Let's run this. Let's import this. All right, so it's downloading data from TensorFlow Keras dataset.mnist. Okay, that's cool. That's all we needed to know. I usually just hide it unless I need it. Otherwise, it gets too crowded. All right, so the next thing that we can, now that we have our data set already imported, now let's do, let's look at the first image, okay? We'll do, uh, show the first image. All right. And to show the first image, what we're going to do is, like, this code basically loads the data set, and, right. So with this code, as I said, uh, loads the data set and displays the first image, right? The label tells us what number this image represents, okay? Here is the label, okay? All right. So this is what we did. All right. So now let's, before training, we need to prepare the data, right? As we have talked about before. So AI models learn faster when numbers are small and simple. So we'll scale pixel values from 0 to 255 to 0 to 1. Okay. So here's what we're gonna do. Let's Okay, and then we're gonna add the code here. So this makes, this makes, all right, no, okay. So what we did is we told the machine to that you don't have to go down the path of looking at every value between 0 and 255. We're fine if you're just looking at the range of 0 to 1. All right. So that's basically what we did. And then, what we're doing here is that, training more efficient. Now, we can do we can do a better accuracy. I hope we'll get a better accuracy, right? So now, what we'll do is we'll use a neural network with three layers: an input layer, a hidden layer, and an output layer. Okay, so let's do that. We're going to define the model first. Okay, we're going to define the model, and our model would say, okay, let's run this model. All right, so the model is running as well. So you can see that layers reshaping flatten pi 37. All right. When using sequential models, prefer using an input shape object as the first layer of the model instead. Okay. I would go back and hide this. All right. So with that said, let's go to our next step. Okay. Uh, if you but before we go, let's look at what is happening here. Okay. We've flattened layer, right, converts a 28 by 28 image into a 1D array. Okay. And that's called flattening it. So the first thing this model is doing is flattening. And the second thing is dense layer, right? So 128 neurons process the image. So 128 activation, that means that 128 neurons process the image. And then the softmax layer that basically outputs probabilities for 10 possible digits, 0 to 9. Now that we have this, let's train this model. Okay. So to train this model, uh, before we train it, we'll compile it. All right. Here's what we're gonna do. Next is we're gonna compile what we've done, our model. And the compile. Yeah. Let's compile it first. Yep. All right. All right. So the next we are going to train the model. All right. So what we're going to do, let's set limits, and in the training model we will set the apex, right? Let's restrict the model to 5. All right. So after 5 rounds, it's going to stop, right? After 1 of 5, all right? All right, so we ran 5 epochs, and that means that we asked the machine to run to get training 5 times. As you would see, right? I mean, what we're measuring here is how long it took, right? The latency and step 3 milliseconds. Look at the accuracy when in the first one is 0.87, but in the second, accuracy goes to 0.96, 0.97, 0.982, and then 0.988. So the more training the model went through, right? The more it was trained, the better it got. Okay. All right. So now that we know I've trained the model, right? So what should we do next? Now we should evaluate, right? So we're gonna test it. We're gonna test the model. Let's call it test. And all right, so let's test the law. Great. Okay. Now let's make a prediction. Okay. So all right. Now first thing that we're gonna do, I've already did I import NumPy or no? Just to be safe, let me just do this again. I may have already done that, but let me do this again. All right. So what are we gonna do next is we will do some prediction. Okay. All right. And do this. Okay. All right. So here you have it. And you've already built an AI that can read handwriting, right? But if you want to train a custom AI model for any task, that's coming in lesson 3. But I would hope that you'll go back and spend some time. I will provide this code in the as well. Go ahead and start playing around with TensorFlow. I'll see you in the next lecture.